Today I'm going to show you how to build a circuit, typically Astable mode, using 555 timer or the multi-vibrator IC. So you can see that here in the middle we have our 555 timer IC, which is in dual inline package or DIP package. Here we have a 7805 IC or voltage regulator. If you don't know about it, please don't worry, I will explain about that later. It is just an IC which regulates the voltage or just gives us a linear voltage of a certain level. It is a 7805, so it gives us a 5 volt output. So now, as we know that 555 timers actually give us a square wave as output. So here we can see the LED is blinking. That is the proof that we are getting a square wave as output. Now the square wave, for the square wave, the output goes high for a certain amount of time and low for a certain amount of time, and that causes the LED to blink. Now here you can see I have a capacitor, a output resistor, a output LED, a input resistor. This capacitor is known as input capacitor because the charging time of this actually controls the flashing time for LED. Here I have connected 3 resistors in series in order to get a 10 kilo ohm resistance, and here I have a single 10 kilo ohm resistance. You can also use identical resistance like this, so you do not have to use these 3 resistances here, but I didn't have any 10 kilo ohm resistors left, so I decided to make one for myself. Now you will need some jumper wires and of course a power source. Now if you are a engineering student, typically a applied electronics engineering student, then you should know how to build a circuit for Astable mode using 555 timer. And if you don't know, don't worry, I will give the circuit diagram in the description and you can get it from there. Now you can see that I have used electrolytic capacitor here, which are polarized. So be careful when using them because the polarized capacitors are very fragile, and if you connect them in reverse polarity, you might face an accident. This can blow up easily. So be careful about that. And if you see your circuit, your IC, just touch it here. If you see your IC or your capacitor warming up, then immediately remove the power for safety concerns, because if they warm up, so they are actually drawing very much amount of power, and that is not a good sign actually. So I have connected the circuit as in the diagram. The diagram is like this. You can take a screenshot if you want to. Now, as we know that the value of the capacitance, when the value of the capacitance tends to get bigger, then the flashing time of LED will also get larger. For example, it is a 10 microfarad capacitor. If I remove it and replace it with a smaller valued ones, then as the theory goes, we should get a higher frequency in the output. So let us do that. As I said, it is blinking much faster, and I am using just a 4.7, no, it is maybe around 2.2 microfarads. It is a 2.2 microfarads capacitor, and here I was using a 10 microfarads capacitor before, so it was blinking that slow. Now we know that the duty cycle for this is not exactly 50%. You can never get a on time and off time. The ratio of on time and off time 50%. You can never do that. It is not possible. So if we give it a larger value of capacitance, we can see that the on time is always greater than the off time. Like here I have a 100 microfarad capacitor, and if I put this on, you will be able to see this. Just wait a minute. Now as you can see, I have put a 100 microfarad capacitor here, and you can see that the on time of the LED is greater than the off time of the LED. So you can say that the duty cycle is not exactly 50%, it is actually greater than 50%. So you can make these kind of circuits at your home. And any 555 timer is a really interesting IC, because you can also make mobile network jammers and also amplifiers using this. And the voltage regulator over here is made using this 555 timer IC, which I will explain later, maybe in the next video. Thank you for watching.